up here, it's just looking at, it reminds you of that equation. We're going to need it still, and we're going to talk about what we need to do to construct a model for this. So, for these functions, like I said, the first few are going to be just a little bit of review, but then we're going to look at putting these into real-life situations. We will be doing this both with a calculator and without a calculator. So when we were doing like modeling problems, you know, a lot of times we put stuff in L1, L2, and we get the calculator to give us a model. We will do that some in this section, but I'm pretty sure it is one of the FRQs. I think the fourth FRQ. The good thing about the PreCal AP exam is they have told us what is going to be on each free response question, and the fourth one is going to be a sinusoidal modeling problem without a calculator. So we definitely need to be able to do this without a calculator, not just by typing it in. Now on the multiple choice, you may see one where you need to be able to do it with a calculator, but the last FRQ is going to be a sign modeling problem without a calculator, so we got to be ready for that. So f is a sinusoidal function here. The graph y equals f of x is given above in the xy plane. What is the period of f here? What would you guys say for that one? 2. It is 2. So definitely some different things you can look at. Now, you can look at like maximum to maximum. It does sort of fall in between, but this would be negative 1.5. This would be 0.5. If you subtract them, 0.5 minus negative 1.5 is going to give you 2. Or you can kind of, I like sometimes to start at the y-intercept and just follow the graph until you get back to that y-intercept, and then it's just 0 to 2. And you can see it that way. But that is the period of the graph here. All right, 2 gives us this equation right here. Which of the following values could represent the constant c? Okay, so in this equation, we've got a -1. That is our midline right here. We also have a 2 right here. What does that do to our graph? It compresses horizontally, right? So, because everything on the inside is backwards. So it's compressed horizontally. It's going to change the period. So the period of this function should be 2 pi divided by 2 right there, which is going to give us pi. And you can kind of see like minimum point to minimum point has a distance of pi. So that's given to you. Now, if you were just writing, if this was delta math, if you were just writing this equation, this particular graph starts at a minimum point. Its y-intercept is at a minimum point. What would you guys do if you were just writing the equation for it to make that happen? You could flip it by putting a negative out front, right? However, does this equation have a negative out front? It does not. And this did not ask us to put a negative out front. That's not an option because this is a multiple choice question. The only way we can fix this equation so that it matches is to put a plus c. So let's just think about what this graph would look like. Y equals cosine of 2x minus 1. Before it shifted left or right, right? Cosine usually starts at a maximum point, right? And so this function would look like this if it had not been shifted. If it was just regular cosine, it would look like that purple graph right there. So how much do we need to shift that so it lines up with the function that we see here? Pi over 2. This maximum point right here needs to slide. Does it matter which direction it slides? It could go pi over 2 to the right and it'd be at a maximum, or it could go to the left and it would be a maximum. So we could use a pi over 2, a positive pi over 2, or a negative pi over 2 for this one, but they're not going to put both of those as answer choices because they could both be correct, so we're just going to pick pi over 2 right there. So sometimes in a multiple choice situation, they're going to force you to do something you wouldn't do otherwise if you were just writing the equation for that. Okay, let's get into some actual application. Okay, so a yo-yo that is attached to a 30-inch long string is rotated at a constant rate. The figure provides a representation of the yo-yo in the XY plane with the direction of rotation indicated. At time t equals 0, the yo-yo begins to rotate. The yo-yo is at the start position in the figure. At time t equals 5 seconds, the yo-yo has completed 20 rotations, and the yo-yo is in the same position as it was at time t equals 0. A sinusoidal function is used to model the x-coordinate of the position of the yo-yo as a function of time in seconds. Which of the following functions is an appropriate model for this situation? Okay, so this is not really, that's just a little bit weird. Because I'm trying to figure out. I'm thinking he's talking about the situation like with a yo-yo. I know that, like you have one of those ones that will like spin at the bottom. You can do tricks with them better if they got the spinning feature. And so you like, it's not going up and down. It is going to the bottom. I don't know if that's what it's really talking about here. Maybe this is more of like you're doing a trick and you're spinning it around. That might be more what's happening. Because I think this dot is our yo-yo. Because it could be either one. But the, like, radius here is 30. So that wouldn't be your radius of the yo-yo. Like if the yo-yo was just spinning and we were looking at like a point on the yo-yo, it should be much smaller. So I think actually what we're looking at is like somebody's doing a fancy trick on this yo-yo. Or it's a little kid that doesn't know how to yo-yo, so they just like take the string and sling it around like this, like anybody that comes within 6 feet of them is about to get taken out. So I think that's what's happening actually. So if we look at this, if we think about taking this circle, it's a lot like the unit circle. If we think about taking this circle and making it a graph where this is our height and this is our time. Okay, what is the highest point that the yo-yo is going to reach? It's going to hit 30, right? Up here at its very highest point, it hits 30. At its very lowest point, it's going to hit negative 30. So here, like wherever your center of rotation is, they're just counting that like it's 0 here. So now, where does our yo-yo I don't know about these answer choices. I should have worked through this ahead of time. Because where does our yo-yo start? It starts at negative 30. Are any of these going to start at negative 30? No. They are not. Yeah, I think there might be an issue with the problem itself here because of, I think it would need to be shifted over because that start is going to be at negative 30. You're starting at the bottom there. So, but as you go around the circle, it takes like 4 increments to go around the circle. 1, 2, 3, 4. And it'll go to the middle. It'll be up at the top. It'll go back to the middle. It'll go back down to the bottom. And then that'll just happen again, right? Over and over. So really, let's ignore the fact that this starts at the bottom. I feel like he should have put the start position here in order for this to work like he's wanting it to work, or he should have done cosine and put a negative or something here. I think our answer choices have a little bit of an issue. I will look into that to see if he's got an explanation for why he did that, or if it was just a typo. So really the only difference between these four options are our like b value, right? And what does the b value affect about our sine function? Does it change like our amplitude, midline, period, shift left or right? What does it do?
Oh, sorry.
That b value, that number that's multiplied by our variable here. What does that change? Does it change our amplitude? No, that'd be the 30, right? Does it change your midline? No. Change the period of the graph. It's not the period of the graph, but it changes the period of the graph. So we've got to figure out what the period of this graph is. Okay? So what information do they give us that would help us figure out what the period of this graph is? That is going to be the amplitude. That tells you how high or low this is going to go. At time 5 seconds, 20 rotations, and it's back to where it started, right? So we've got 20 rotations in 5 seconds. How many rotations would that be every second? Okay, so we got 4 rotations per second. What is our period? Well, first of all, is 4 our period? I'm guessing maybe no, since I was changing my question there, right? 4 is not the period. What is 4? It's a frequency. This is your frequency. It is how many rotations you have in a given time period, right? Our frequency is 4. The period is how long it takes for one rotation, right? So we're thinking about let me use a different color. We're thinking about from here back down to the bottom point. We want to know how long that will take. How long will that take? What? It'll be more than 5. Well, let's see. Are they telling us? I don't think. Yeah, no, it won't be 5. 5 seconds would be 20 rotations, so it would be 20 times for that. It's not 4. No. It's 1/4. Because 4 full rotations is in 1 second, right? This should do, that part I have highlighted should happen 4 times in the first second, right? For there to be 20 in 5 seconds. So this would be 1/4 of a second right here. Remember, frequency and period are reciprocals of each other. They're flipped. So if your frequency is 4, which is like 4/1, then your period would be 1/4. Right, so like if you think about drawing out 4, like here's 1 second, you need 1, 2, 3, 4 full rotations for that, right? Like right here, 1, 2, 3, and 4. So it would take that and split it into 4 sections, so it'd be 1/4 there. Okay. But this number is not the number that we use for our B, right? In fact, I would go ahead right now and throw one of these answer choices out. So we said we were not putting 1/4 in as our B. So which one could we throw out because it's basically just 1/4 times t. A could go out because it's not written like this, but this is the same as 30 sine 1/4 times t, right? So that's out because the period is just plugged in, and that's not how we find the b. To find the b, we do 2 pi divided by b equals the period, which is 1/4, right? So we would cross multiply. B would equal 8 pi. And so D is going to be your answer choice for that. Although, I think instead what he really should have done, if you can write this here, f of t really should equal negative 30 cosine of 8 pi over t. Because if it starts at the bottom, sine is not going to start at the bottom. But if you do a negative cosine, it'll start at the or negative cosine, it'll start at the bottom. I really think he probably should have done that instead of what he did. Okay, questions there? All right. Let's look at another one. A clock is mounted on the wall at the point P. Let's see. At the point P is located on the tip of the minute hand of the clock. The function h represents the height of point P from the ground at time t, where h of t equals a sine b t plus c plus d in the xy plane. The points h equals 0 equals 70, h of 30 equals 52 represent a maximum value and a minimum value, respectively, on the graph of h. What are the values of a and d? Okay, so let's think about what we have here. We've got a clock is on the wall. So here's our clock. And we've got our minute hand. Well, let's see. We'll put our little hour hand over here. But we're talking about the minute hand right here. And this point at the end of that minute hand is our P. And what's going to happen as P is going to go around the graph in the clockwise direction. And it will give us our values here of the function. Now, what numbers are they asking us for? Or what letters do we have to find? What letters do we have to find for this one? A and D. That means they're asking us about what two features of the graph. A gives us amplitude, D gives us midline. It makes it harder if you are talking about the period and the phase shift on this, but they're not asking us for that. They're only asking us for our amplitude and our midline. So if we think of this graph right here, put our x-axis down here, we've got the point 0, 70 right here. And then over here, we've got the point 30, 52. And it tells us that these points represent a maximum value and a minimum value respectively. So that respectively means in order. So that's our maximum, that's our minimum right there. So our graph should look like this here, right? Our highest point should be 70. Our highest point should be 70. Our lowest point, the y-coordinate, is 52 right there. And it's only asking us for A and D, so we just need amplitude and midline. Let's find midline first, because amplitude is the distance from our midline to our maximum point, so I'd like to do midline first. How can we find the midline?
You just like slowly fill it going up on the Y.
Probably count like sort of
Yeah.
counting in. You could. What would be faster? Find the average, because that's going to give you the number halfway between those two numbers. So for D, you could just do 70 plus 52. Make sure you're using the Y coordinates, because that's what we're talking about for midline. It's a Y equals. So 70 plus 52 divided by 2, which is going to give you 122 divided by 2, which will give you 61. Did I do that right? Yeah.
Or you could have just saw that if there's 18 in between it, add 9 to
Yep.
2.
That'll work also. Okay, so our midline is right here at 61. What would our amplitude be? 9. So A is going to equal 9. And this problem doesn't ask us for B and C. So we don't have to think about how we shift it over or change the period, because definitely your period of this has been changed. We just have to find A and D for that. What is the period of that graph, though? It's 60. Think about a clock. The period is how long it takes for a full rotation, right? So a clock, if they're talking about the minute hand, it's going to be 60 minutes. If they're talking about second hand, it's going to be 60 seconds, right? That's how long it takes you to go all the way around. And I did see a question the other day about a broken clock that was going twice as fast as it was supposed to. So the period was actually 30 instead of 60, but I don't know. No, because period is how long it takes to rotate all the way around. So if it's going twice as fast as it should, it normally takes 60 minutes to go away, all the way around. It'd take half of that.
Oh.
Yeah. If it was twice as slow, it'd be 120. Okay. Here's an example where the equation is given to us. And I believe this is still calculator inactive right here. So the average monthly temperature in degrees Fahrenheit for a town in central Indiana can be modeled by the sinusoidal function given from 1 to 12 months. Based on the model, which of the following is true? Okay, so temperatures throughout the year, particularly in places that have seasons, can be modeled with sine functions very well. Because if you think about what happens in the winter, it gets very cold, your temperature is low. Spring gets in the middle, summer it gets hot, fall it's back in the middle again, winter it's cold again. So it just keeps going over and over again, right? We have the maximum average monthly temperature is 61.2 degrees Fahrenheit. We have the maximum average monthly temperature occurs at M equals 1 month. The minimum average monthly temperature is 35.5 degrees Fahrenheit. And the minimum average monthly temperature occurs at 7 months. So let's talk about each one of these. So if we were to sketch like a graph of what is happening here, we've got, where is our midline going to be? $61.2. So our midline would be at 61.2. Okay. Where would the maximum points be? If we drew in a line for where like our highest was at and our lowest right here. What would the highest it ever goes be? Or how would we find it? 25.7 plus 61.2, because our amplitude is how far we go above or below that midline. So if we add these two together, we will get 86.9. And then if we subtract them, if we do 61.2 minus 25.7, that is going to give us our lowest. So let's see, we'll have to do some borrowing here. So yeah. Okay, so this is 35.5. So without even going a lot further, which one do you guys think is going to be correct? It's going to be C. Our minimum is going to be at 35.5. A is not correct. That would be like your average monthly temperature. The midline gives you the average of what you're looking at because it goes right through the middle, right? So, so A would be wrong. The maximum occurring at month 1, we would have to think about plugging in a number for this. It would be a lot more difficult, but we feel pretty confident on C, so that's probably not going to be right. Minimum average temperature occurring at 7 months, again, would have to deal with like our shifts that we would be dealing with. Maybe we should look at that though. What would so if we're looking for the period of this graph, to find the period we always look at this number right here. But it is not that number. The period is not pi over 6. What do we do to find the period? Two pi over b. So 2 pi over b is going to be 2 pi over 6 in this case. In this case, we're not finding b. This is b, right? The number in your equation is b. So we would do 2 pi, dividing fractions, easy as pie, flip the second, and multiply. We would get 12 pi over pi. The pi's would cancel, and we would just get 12, which should make sense, because how often should your temperature start to repeat? 12 months, right? Because every year, it just is the same pattern over and over again. So, so what would happen here is a normal sine function. If it was a normal sine function, it would start right here at the midline. It would go to the maximum, midline. Right, that should be a 9 right there. Minimum, back to the midline. Those are the points we'd have for a normal sine function. But this particular graph has been shifted. How has it been shifted? To the right 4. So we would go to the right 4. So all of these points would be moved to the right 4. So like this right here, this maximum right here that's at 3 would be moved over 4 points, and it would be at 7. Right? And then the minimum point right here, it would be moved to the right 4, so it would be moved over to 13, which would correspond to 1, because this would happen. I need to use a different color. This is all running together. Let me switch screen. So we're switching to these points, these points. This one would be moved over 4 points. It would be right here. That one would be moved over, and it's going to be off the graph. This one right here would be moved over 4 points. So we'd have a graph that looks like this. So these two are just switched because this says the maximum is going to be at month 1. What's really happening at month 1? Minimum, right? And then this says there's a minimum at month 7. It's really a maximum there. So if C had not been our right answer, that's how we would distinguish between B and D for that. Okay, questions? All right, everybody grab your calculators because we're going to use our calculator for this next one. I'm pretty sure. Hold on. Yeah, because it says regression. Okay. Let's see. I need to get my calculator out. Okay. So, much like everything else we've done using the regression on the calculator, where do we go first? Stat, edit. We are going to put our numbers into our calculator. So everybody get your calculator and follow along with that. Almost. This is not going to be a linear regression. What kind are we going to use? Sine regression. So once you get your data in, you're going to go to Stat. You're going to go over to Calc. And our sine regression is C. And our calculators will not do a cosine regression. So if you're doing a regression, you have to use sine. Even if cosine might look like it would fit better. And you have to use sine. I haven't used the calculator for this in a while, and I haven't used the updated version. I guess we'll just leave this for 3 for iterations. Does y'all say 3, or does it say something different? Let's just leave it 3 and assume that's going to be okay. Oh, okay. Let's go up here. It says 16 iterations in the problem. I've been using Desmos so long for this. Oh.
Mine came up y equals a sine bx c plus b.
Has your calculator not been updated?
It has. Because I did the chord thing. But you see how mine has like the equation and then...
You have already done it. I think you just hit enter too much. Go back to stat.
Oh, I already hit calculate.
Yeah, you already hit calculate. That's why it is.
Sorry, I thought we were...
Yeah. So we have not hit calculate yet. So it's probably still fine on that. I'm not sure. So 16 iterations. L1, L2. I don't know about this putting a number in for the period. We're going to leave that blank and see what happens, and we'll check his answer key to see if it looks right. And let's store this in Y1.
Wait, so we do leave it like iterations?
Yeah, it. And let's put this in Y1 and calculate and see what we get. Yeah. You guys getting the same as me, 3.117? All right, let's check and see if he's getting the same thing on his key, just because I've not used the 89 for these in a while. I've been using Desmos, and I'm not sure about typing in those iterations or the period. And I'm pretty sure last time I did sine regression, my calculator wasn't updated, and I didn't have that option, so. Oh, that's the worksheet. That's not little notes. Oh, well, he didn't even. Okay, he didn't put much detail on his answers here, so let's just see if it works. Where we at? Okay. All right, so it wants to know what is the maximum number of nighttime hours predicted by this sinusoidal function. So we could go to our graph and find a maximum point. That would work for this. But it takes a little longer. Plus, you got to get your window right, and it's just kind of aggravating. What else could we do to find the maximum? Midline plus amplitude is going to give us our maximum, right? So we could do 8, we could do our 8.215 plus our 3.117, and it is going to give us a little bit more than 11 for this. If the problem tells you iterations, I guess put in 16. If it doesn't, I guess it doesn't matter.
Where's the 16 coming from?
Yeah.
Okay, I see it now. Sorry,
Yeah, I overlooked it the first time too. I think that just means, like, if you graph this, it's just going to do it 16 times and it'll quit. Or maybe it's something with how it calculates. I need to learn more about that. All right. That gets us to the end, right? You guys have, that's it? Okay. All right, so